Good morning everybody, I am Riccardo Rosati, a PhD student from the Department of Information Engineering, Visual Robotics Artificial Intelligence Group from Polytechnic University of Marche. Nowadays, there is still a lack of software instruments for the automation of quality control procedures, which focus on non-metric but qualitative analysis. For this reason, the traditional quality control process is usually limited by the high time-consuming and high resources demand, in addition to a limit in performance mainly due to the high intrinsic variability across different annotators. The application of deep learning strategies for solving the quality control task opens the realm of possibility to overcome these challenges. In particular, in this work, we focus on the static quality classification of free-fall stocks, based on the analysis of the wood grains. Today, this quality control task is entirely based on the evaluation of the human eye. The aim of our work is to propose a deep learning methodology in this unexplored and challenging quality control application, and a proof of concept for detecting and mitigating unwanted bias in the collected real dataset and in the outcome of the deep learning model. The collected dataset of wooden stocks is composed of 10 categories ranging from grade 1, which indicates almost valence wood, up to grade 5, with a very twisted and variegated grain pattern, for a total of 1,902 images acquired in a top view configuration. Following company demand, we divide the problem into 3 different quality control tasks, sorted according to the level of difficulty established by the company itself. We solved each multi-class classification task independently, by considering a fine-tuning strategies of 3 state-of-the-art CNN models and 2 different loss functions. The experimental results demonstrated that for each task the VGG16s overcome the ResNet50 and AlexNet models. Moreover, the ordinal categorical cross-entropy loss is more reliable for solving all the tasks. Although the proposed deep learning model based on VGG16 has been proven to be reliable in solving the quality control task, it is not immune to those who may be unwanted bias, such as the typical characteristic of each shotgun series. Considering that each specific rifle series is bounded to a specific quality class, this may lead to an overestimation of the model's performance, thus reflecting a more focus on the stack geometry than an evaluation of the wood grain. The proposed two-stage solution named hierarchical unbiased VGG16 is able to separate the shotgun series prediction model task from the quality class prediction quality task. The single network of the first stage predicts all the shotgun series. Based on the shotgun series predicted, we assign a specific second stage subnetwork for classifying the quality classes. The higher performance, up to 0.95 of F1 scores, by the proposed UVGG16s suggests how the proposed approach represents a solution for automatizing the overall quality control procedure in this challenging industrial case scenario. Thanks for your attention.